Good morning, everyone. My name is Francis Mburu, and I'll start by thanking the organizers of this symposium for their kind invitation. It's difficult for the Kenyan team to come here, and they really supported my team. Even at one time, they had to change the ticket because getting a visa to come here was quite difficult. So thank you very much. So my presentation is on wood dimensional stability and extractives as reasons for termite and fungal resistance for a lesser known tree species in Kenya, Albizia maracophyra, which is used for wood carving. In my introduction, wood carving plays an important role for mostly African countries for the economy and as an exchange, as foreign exchange earner. Wood has traditionally been used to make various products that show historical activities by different tribes. For example, in Kenya, we have 42 tribes, out of which more than that tribes have the tradition of making these sculptures, and they use wood and stone. Attributes for species preferred for wood carving, we have different properties that we look for, or the wood carvers look for as they make their sculptures. I've given some few examples. We have strength, such that the wood has to be strong enough to resist bedding and breakage. 2, it has to be durable. 3, the wood has to be soft for easy walkability. For example, the wood carvers who are out there, they are using very good wood I really tested, and it's quite walkable by very simple tools. Wood has to have beauty, the aesthetic value. It has to have very good color, grain, and pattern, so that at the end of it, we have very good sculpture to show exactly what you want the community to learn. Initially, major wood carving species supplied enough for the industry, but due to growth and population, the demand for wood in carving industry has exceeded the supply. That is supported by what my Tanzania colleagues say, that the demand for wood in African countries is quite high, and the supply is diminishing. So we have a real problem. This could be attributed to the slow growth of the major wood carving species. It's obvious that most of those hardwoods that we use for wood carving take a long time to mature. And then we have very little research which has been input in this industry. And in that case, the wood carvers opted for alternative species with very little or no scientific backing. And selection of such species is based just on the indigenous knowledge by the local people, which is quite difficult, because most of that knowledge has not been documented. In our Kenyan situation, wood carving takes or uses over 50,000 trees, estimated to be about 8,000 cubic meters annually. And the collapse of Kenyan population of the most of the species that are used for carving, namely muhogo, mpingo, and other carving species, led to smuggling of hundreds of logs from Tanzania. As my friend said, most of the wood that was smuggled from East African countries were brought to Kenya because of the high demand. And such shortage led to those people, the wood carvers, looking for other sources, alternative species. Those alternative species included Azacrada indica, Jacaranda, Grevillea robusta, Mangifera indica, and my Albizia. I think I've saved a different version, but Albizia maracufora is another alternative species which is being used by the local people. The annual liable cut, for an example of this Azaraca indica trees with more than 50 centimeters diameter in Kenya species, is over 200,000 cubic meters. So that confirms that we have a lot of this Azadirara indica, and currently not much of it is being utilized. These species alone could supply a wood carving industry for a long time at the current rate without ecological consequences. But we don't have any research yet on the properties and other effects. Important features of a wood carving species, maybe is a repetition, but durability is of paramount importance because it indicates the service life of such. We have the mechanical properties that include hardness to resist damage of the outer surface. We have the physical properties that include density, texture, figure. Moisture level is also paramount. I don't know what happens to the wood carvers who are already doing it, because some of them are using very wet wood. So moisture is of paramount importance as you do the wood carving. Then we have the anatomical features which help to predict the behavior of the wood, especially during seasoning, and that confirms what my Brazilian colleague talked about, the wood anatomy, the vessels, the size, the grain, the texture. So these are very important factors and features that we must get to understand. Classification of wood carving species, majorly three main groups, where the major group were found in almost all carving areas. Those include Brachia meraxonin, Olea europea, and Brachia urensis. Then we have the minor species. These are occasionally used as alternatives to most of. These are occasionally used as alternatives after the shortage which we have already recorded, and such include Terminaria browni. We have Albizia maracufera, Azidraca indica, Jacaranda, Mangifera indica. These are used as minor species, but we are trying to come up and understand more of these alternative species. Alternative species have not been widely used for wood carving. So what do? We need to understand more on the properties. It's why my research really dwelt on these Albizia species, and I tested the durability. The first thing that I did, I tested the resistance of these wood species against fungi in the laboratory. And the test was based on American wood preservers standard method, where the hardwood samples were cut to those dimensions. Some were extracted using different solvents. The solvents included hexane, dichromethane, water, toluene, and ethanol. Then I used unsterilized soil bed in those in a container of those dimensions, 250 by 150 by 170. Then I incubated at temperatures ranging between 22 to 25, and then control the moisture levels to about 70%. The fungal decay was assessed by mass loss. In the lab, the petri dishes were used. These are 9-centimeter petri dishes that were filled with mud agar and injected different concentration of wood extractives from 0, which is the control, 50 to 50 ppm, to test the effectiveness of extractives against the fungi. And then the inoculation was done and incubated for 9 days. Evaluation was done and inhibition was calculated by use of that formula to see the effect of extractives on the growth of the fungi. Then on dimensional stability, I used 16 hardwood and 16 sapwood specimens of 20 millimeters by 20 by 20, then computed the volume, initial volume, for extracted samples and not extracted samples, and then these were exposed to desiccators that were full of copper sulfate for hydration, and then the weight was monitored continuously until constant weight, meaning it has already absorbed enough, and the volume change was computed. Then the swelling coefficient was computed by use of that formula and compared with the control. Wood resistance against termites in the field. I adopted standard formula. I adopted my formula based on the American Wood Preservers standard formula, AWPA of 1993. The specimens were cut to those dimensions, 100 by 10 by 5. Some were extracted, some were not extracted. Pine was used as control virulence and conditioned at 60 degrees Celsius. These were exposed to active termite nests, and the extent of attack was evaluated by weight loss, and computation of the amount of wood which was lost by the termite attack was computed by that formula. Some chemical analysis was done by use of FTIR analysis. We don't have that one in Kenya, but I sent samples to France, to my professor in France, and he injected and sent back the results. And a standard procedure was used where 1 microgram of that extract was mixed with potassium bromate, and then we have the spectra in the range of 4,000 to 500 per centimeter. My data was analyzed by use of Statistica version 7 for Windows, where I compared the means. My results showed that Arbizia maracofora hardwood is dimensionally stable with a coefficient of swelling in the range of 5.5%. It also indicates strong hydrophobic nature. It doesn't like to absorb water, that is. And dimensional stability was significantly lowered by removing extractives. That graph is a representation of weight loss in the lab test, and if you can see the top curve, which is for Pinus patura, it's obvious that most of it was attacked, really attacked, and the blue one, the lower one, is an extracted species of this Arbizia maracofera species. species. The others we have in the range of between the pine and the unextracted. So you can see after extraction, especially hexane, after removing the extractives by use of hexane, the wood was really attacked. So maybe hexane removed what has the ability to protect against fungi. Those are just petri dishes showing inhibition. The last one, which is quite white, is the control. Second one is shows the growth at 50 ppm, and the last one here shows almost no growth, which is at 250 ppm of the extractive. It is the same representation on this graph here, which shows that at high concentration the inhibition is quite high. Same results down there by the look of it. The blue curve shows that the control after 9 days was quite big, and then the red one shows that there was very slow growth at high concentration of the extractive. Those ones are photos that show the last on that end shows Albizia species, which is not extracted, after 6 months in a termite nest, active termite nest, no attack. The other three, we have the sapwood in an active nest for 6 months, almost no attack. This one here shows extracted Albizia in the same nest, and after 6 months, you can see the amount which was eaten by termites. So it shows that after extraction, we have an effect by the attack by termites, which was really significant. Same representation on that other graph. That one is a representation of what my professor sent me after analyzing the compounds. He told me that most of those peaks showed that the extractives had a lot of aliphatic compounds, carboxylic acids, ketones, and those and other phenolic compounds, and these are quite, they have been associated to inhibiting attack by fungi even from literature. So in my conclusion, I would say Albizia maracophylla heartwood is dimensionally stable. The heartwood contains very high amounts of extractives. Removal of those extractives have or make wood less stable. Durable, this wood is durable against fungi in the soil bed, losing very little. This wood is very resistant to termites, where we recorded weight loss of about 4.8% after 6 months. The infrared analysis showed presence of aldehydes, ketones, carboxylic acids, and aliphatic compounds. And to sum it all, the natural formation, amount of heartwood extractives, dimensional stability, and strong hydrophobic properties are at the origin or are the reasons why we would say Albizia maracophylla is resistant against termites and fungi. I thank you very much.